this time, I'd like to introduce our presenter. Bernard Sokold is Senior Product Marketing Manager for System Sensor, specializing in the FAAST aspiration product. Bernard, take it away.
Thank you very much, David. Good morning, afternoon, or evening, everybody, whatever time zone you're at. Before I go into the presentation of the new release of PipeIQ version 2.3.8, I'd like to provide a very, very brief summary, brief introduction of our aspiration system range that this PipeIQ software works with. So let's take it away. We have the full range, full family of the aspiration system that are suitable for all types of applications from very early warning or standard fire detections, with the coverage, with the sensitivity settings that is fully configurable, that can be adjusted and tailored to any requirements of any project or any application. For starters, I'd like to mention again, how do we position the holes of an aspirating system, which you're probably all familiar with. So every hole, every sampling port located on the pipe reflects the positioning of a smoke detector, because this is what the aspiration system detects. Obviously, you can make the distances or spacing smaller. You should not ever exceed the distances that the regulators or local AHJs or regulations allow. So if you consider that those small dots that you saw in the previous slide were the spot detectors or point detectors, when you connect the dots, you would have exactly the same or very similar configuration on the ceiling or somewhere else, whenever required, where the sampling port is at the place of the smoke detector. In most of the worldwide, in most of the regulations, the spacing between the holes reflects the class that the unit works in. So from standard fire detection in the UL world, the distance between the sampling ports should not be larger than 30 feet. And then from the wall, it should be half of it, which is around about 15 feet or 4.5 meters. In EN54 worlds, like the European countries, for Class C, which is a counterpart of the standard fire detection, FSD, that distance in most European countries is 10 meters. Some countries have a different number. Obviously, the early warning fire detection has that distance smaller, from 30 to 20 feet and 10 feet from the wall, and very early warning has that distance made even smaller to 14 feet between the sampling ports and 7 feet from the wall, or in EN54 world, in most countries is 5 meters and 2.5 meters from the wall. So what does our PipeIQ do? It helps you to design the system, to configure the system, and monitor the system. We have made sure that the software is as intuitive as possible, and when I jump into the proper software presentation, when we have the possibility of a live demo, I would like to show you what's new in comparison to our previous releases. But this slide just shows the individual icons that I think should be very easy to decipher. So I'll try to point with an arrow of what I'm talking about. So those icons on the top line are the Pipe Wizard, which is a very easy way to design simple system when you have the rectangular or square kind of building, where you provide basic data about the sizes of the room, height, etc. This is enabling you to add a detector manually. And then when you work with the software, obviously when you hover over in each individual icon, you have the prompt telling you what this icon means, so it's very easy to navigate across the software. when you start designing, or when you design the system, and you can design anything from a very simple rectangular or single pipe to 4 pipes or 4 branches configurations, you want to be sure that what you have designed is actually reflecting the regulations, is that all parameters are correct. So by clicking the calculator button, it tells you if you have done something wrong. And if you did, and I highlighted it especially, there was nothing wrong with the design that you saw in the previous slide, but I did highlight it so you could see very clear that if something is wrong, it will be immediately flagged, immediately highlighted in red, whatever parameter is wrong at that stage. And to complement for that design, as if it was your 3D paper, 3-dimensional paper, you have those 2 tabs. First one, the one on the left-hand side, is the configuration tab, where you can configure the software configuration, the times, the sensitivities, and everything that is required to make the unit work correctly. The other tab on the right-hand side is the monitoring tab, where when you connect to the unit, you can monitor in real time how the unit behaves, as if you were standing in front of the unit, and it doesn't matter whether the unit is like 1,000 miles away, as long as you have the connectivity over the TCP/IP or USB for Fast Access or XT, you are able to have a look or monitor the status, the event logs, etc. So let's get started. Let me just share the screen with you, where I will show you my PipeIQ. I hope that some of you at least has a software installed on your computers, so you can replicate or you can copy what I'm doing on the screen. So let's just start with opening a new project. I realize that there is some lag, some delay when I show things on the screen, so I'll try to respect it and give it at least like 1 second before I click the next button. So let's call it a webinar 1. Okay. We acknowledge that, okay, we understand what System Sensor does provide, does not provide. We select the measuring system. So is it either the US customary system or metric? For now, let's stick to the US customary. And then we have the next window ask us which of the FAAST units we want to work with for starters. So let's select FAAST XM. Click OK. And for starters, as I showed you before, we need to visualize where we want to position our holes. So probably you have it in your mind always. So when you start designing the system, you first double click on your 3D paper, because the white space in front of you is the 3D paper. So let's start with the easy stuff first, which is the Pipe Wizard. When you click the Pipe Wizard button, the windows open. The window opens, a pop-up window opens and asks you, well, what kind of system you would like to design, in what kind of constraints, in what kind of regulations. So for now, let's stick to UL and ULC. And let's start with standard fire detection. It tells you the maximum coverage area, which obviously you can shrink, you can tailor to your needs. You can also adjust the time constraints. So for standard fire detection or class C in most countries is 120 seconds. Then you can select the pipe material, internal hole diameter. So let's select next, and let's take, for example, a space of 100 by 100 feet, or let's do it 50 by 50, yeah? And then it prompts you, it shows you what kind of configuration, pipeline layout is suggested for that kind of room size. And you can obviously choose between detector location inside of the room or outside of the room. And please remember that when you locate the detector outside of the room, you need to go back with the exhaust pipe to the room that you draw the air from. Okay? You can also indicate what distance from the floor is required. So in metric world, is usually around 1.5 meters. In US customer, it's around 5 feet. And then you click next, and then you ask what is the positioning of the pipe, below or above the ceiling, or maybe below the floor if there are the raised floors that you want to protect. So let's stick to the most common. And then the pipe network direction that you want to see on the screen. And then when you select next, you have the summary, and when you click finish, you have the predesigned system already on your screen. Now those icons, there are those small cubicles, is the view that you can select. So this is the top view, this is the front view, and when I click on it, it changes. This is the right view, and this is the isometric or panoramic view. Now, what you have designed or pre-designed, you want to verify whether the parameters that you have designed are actually correct and actually are suitable for the market that you operate in. So when you click the small calculator, it shows you, oh, I have a problem because I have some red flagged items. This time you see that those 3 columns reflect the sensitivities. Okay, we have in FAAST-XM, we have 5 sensitivity levels. So the best and the quickest way forward is when you want to set the sensitivity whole. So we have selected the, this is the very early warning. Actually, we want it to be standard fire detection. But okay, let's go for the very early warning. When you select the whole sensitivity, it suggests what are the sensitivities that could be the best for that application. So for the very early warning in NFPA 76, you need the pre-alarm at 0.2 obscuration per foot, and a fire 1, which is the alarm triggering level, you need the 1%. You can, of course, you can change it. So from 0.5, you can change it to 0.6, etc., etc. And then you want to export it into the unit threshold. So you calculate the unit threshold, press OK, and then you have all sensitivity levels worked out. Now, how about if you want to change the way the system looks or the pipeline layout looks? It's enough to double-click on the pipe, and you can change the length, let's say from 39.5 feet to 55. It might tell us that we go outside of the very early warning tolerances. And then when you click Update Holes, it should calculate the holes which are applicable to that very standard or that very classification. And then you can see now that we have made the top pipe longer. If you press this icon, you can then change the location of the entire pipe network. If you grow too far, if your network is too big and you want to see the whole extent of it, you then press that very button, which is like zoom to fit. Okay. Now, what else can you do with the network? When you double click on the pipe again, you can add capillaries. You can add capillaries individually. You can change the lengths. You can change you can add all capillaries by pressing the add capillary on top of the column, and then it adds a capillary to every hole that you predefined before. And of course, you can then change it as well. You can also change the location of holes. So when you click on the relative distance column, the cell that you want to move, and then you say, well, rather than 14 feet the spacing, you want to do like 13. You can change it. You can also add hole. You add hole by clicking on the preceding hole, insert, and then this space is split into two. However, you can again change it. So, for example, we'll have, say, 12 feet, and then it should recalculate the distance of this of the next hole. Okay. So when you did some changes, when you've done some changes, you then again you want to click to see if the changes that you've done had some impact or any impact on your configuration. And of course, we've had, because we added holes, so we have made one of the pipes longer. We've added capillaries, so that had an impact on our system. Okay, so then again, now we see that it's only the sensitivities that are in question here. So we set the whole sensitivity again, and let's see the kind of default for class A or for very early warning. When we translate it, it clarifies the whole situation again. Obviously, you can push the system to its limits. However, sometimes it's not necessary. I just want to show you one more thing. When you excuse me, when you imagine that you have wrong type of hole size, which may have an impact on the airflow, on the pressures, and obviously they will be flagged immediately by pressing the auto balance button. In most of the systems, that should help very easy. Okay, so let's now just build the system from scratch. So I need to go back to the configuration window, or configuration tab, click on the floor, right click on the floor, and let's add FAAST XT. FAAST XT is our 4-port unit, which can take up to 28.8 thousand square feet. When you click on it, it again opens up a possibility of a new drawing. So this one obviously is much bigger. So when we build it to say 200 feet by 100 feet, and obviously you can select the number of ports. It does exactly the same, but to a much greater degree. Okay. And last one is I will add it again. I will add the small unit. So I go to configuration. I right click on the floor. I will add our small unit, FAAST XS. And then when I do the design, I need to click on the unit I want to design. I click on my 3D drawing paper and I start design. So I select the detector first. It appears somewhere here there's quite a small one, but let's make it bigger. And I start drawing manually the system. So usually the first pipe is going vertical. Not usually, always it's vertical. Either down, you can have the bottom or the top connection, which is very handy, especially when you have the raised floor applications, or when you have to use the water traps. So when you can select the entry port by double clicking on the unit. So if this is when you select the top, or this is when you select the bottom. So let's select the top, apply. We now select the pipe that we want to connect, and please remember that the pipe that you select is what you see. So sometimes, even if you want to design a horizontal piping system, when you have the plan view, something that goes from bottom to top is a horizontal line. Okay, let me just show you, not to make any confusion. So okay, let's select the vertical pipe. The first pipe can be shorter, so let's make it, say, 10 feet. It will have no holes. It will go from bottom to top, so it will go up. You can also change it from top to bottom, but this time we will select from bottom to top. We select OK. And you can either connect it manually or with the control button. If you click on the device or on the parent pipe that you want to connect, you can connect it automatically by pressing the icon. It's the fifth icon from the left, connect pipes or snap on. And when you click on it, it connects the pipe automatically. I will make it zoom fit so you have a better view. And let's add 2 pipes horizontally, one to the left, one to the right. So I'm selecting the horizontal pipe. Let it make like 10 feet. The first one will go from left to right. This one will not have holes, so I click on it. And you see you have that pipe, which is the child pipe. And then with the control button, and I select the parent pipe, and then I click the connect pipes icon. It connects, oops, the wrong way around. Sorry. Oh God. And then I select the other one. This time we'll go from right to left. Let's make it again 10 feet. Okay. I select the parent pipe. Click on. And now let me select the top view because I want to draw the horizontal pipes that go away from the unit. So whilst in real life they are the horizontal pipes, on our 3D paper here with this view, it will actually be vertical. So let's select the vertical pipe of, let's say, 60 feet. We update holes. We can add end cap. Let's finish that one off with an end cap. And then you select the pipe direction from bottom to top or top to bottom. So we have it somewhere here. Let's see where it is. Oh, it went up to here. But then again, let's connect it quite quickly. Connect pipes. And then we have the first connection of this horizontal pipe. We can also copy and paste. And when I click on the pipe, selecting it, and I select this icon, which is copy, and then I select the next one to the right, which is paste. I have just made a new pipe which is identical to the one that I've drawn before. And this is how we get our manual design. I will show you in a few seconds how we can modify it. Again, when we want to see the calculations, again, we can set the sensitivity holes of, let's say, 1.2, fire 1 at, let's say, 1.8, and fire 2 at 1%, and then you translate it into the unit. And this is how you solve the sensitivity problems. Of course, because of the multiple levels of sensitivity, you can tailor the response times, how sensitive the unit is at each threshold, to the applications that you're dealing with. Okay, so now let's try to rework our existing design. So let's select again the top view, and when I double click on our unit, let's just remove the end cap so it's easier to calculate, and let's just build it a bit bigger. So when we select the settings button, let's select the standard fire detection so we can build it to a much greater level. Okay. So I double click on the pipe, and then I will remind you how to add holes. So by clicking on the hole and then adding insert hole, you add it. It splits the distance by half. Okay, so we can adjust it by adding, for example, 10 feet. Let's change it to a capillary, and let's make this capillary, say, 7 feet long. Okay, you can also change the hole diameter, like a general or generic hole diameter. We usually start with 1/8 of an inch or 3.5 millimeters in a metric system, but you can obviously change it. So let's try to make the system less stable. When I update the holes, it will of course change the numbers, so I want to add that hole again, insert, and I want to change it to, I can't remember, I think it was 10, and there was a capillary, and the capillary was, let's say, 7 feet. Okay. I can also add a small pipe at the end of that very pipe. So let me select the front view, or if it's easier, the side view, and I will add a small pipe which will go up, let's say, by 1 foot from bottom to top. Okay, I will click on that one. Oops, sorry, not this one. Excuse me, this is my pipe. I will make it full screen. And if this is the pipe with no end cap, no. This is the pipe with no end cap. Oh, I need to remove the end cap. And then I click on the child, click on the parent, and add it. Okay? And then I will make it larger again, and let's just add one more pipe, which will be, say, 10 feet with an end cap. We will update the hole, but it will not allow us at this stage because we have too large distances. So let's make those distances smaller. Update holes, press OK, and then we can add it to this small stub pipe, which is at the end of the pipe. And this is how we have designed our kind of unbalanced, unsymmetrical system. Let's check if it works. Well, we have one problem with the pressure. So what can we do? We can either auto balance. I don't want to do it now because I want to show you how we can balance the system manually. So you can, for example, change the size of the hole. Okay, make it smaller, make it larger, and this way you can balance the system manually. Or let's make it unbalanced again. You press the auto balance button, okay, and then it balances it automatically. Okay. Now you can always what you can also do. You can also copy and move the entire network. So imagine that you have a large design, and this design is repeatable. So rather than redesigning it pipe after pipe, you can select all of those pipes. Or you can use the button which is called Select All, and then you copy it. And then, for example, if you want to put it into a different configuration, so you right-click on the floor. Let's add it now to Fast XM, okay, and go into configuration, XM2. We click on the paper and add a detector. Let's make it larger. When you paste it, you have the entire selection on the screen, yeah, and you can connect it very easy. So it saves a lot of time when you have the multiple detector system, but with repeatable layout. Now, once you design the system, of course, let's just close this one because I have disconnected it from the unit. Okay. I will select a different view. I will select the pipe I want to connect. I will select the unit I want to connect to, and I will add the Connect Pipes button. Once you design the whole system, you want to see, well, what have I designed, how it translates into bill of materials, for example. So you can click the report buttons, and then you click the bill of materials, and by generating the bill of materials, you can have a very quick, in a snapshot, in a question of seconds, information of what you have designed and what needs to be ordered. Please remember that very often local suppliers in Europe or in the US, or if you select to purchase the pipes and accessories outside of our company. Now, those sizes of pipes, lengths, etc., or even minimum order quantities may vary, so please make sure that you will order a sufficient number of pipes, accessories, fittings, etc. That's very important. So this is for reference only, but it does provide you with a very good overview of what needs to be done. You can, of course, also select the pipeline layout, which for that for example, system, you want to be sure that you print out and give it to a fire marshal or authority having jurisdiction for verification if your design is actually correct. So you have all the parameters presented. You have at each hole individually, you have the transportation time, the pressures, the sensitivities, and also the positioning of each of such hole or parameter on the system. Okay. Now, the last report that you can make, and this is very helpful when you have a multiple unit system, is the consolidated bill of materials, so that you don't have to print out each individual unit with its own accessories or pipes, but you can add them all together either selectively, or you can click on select all and then generate, and again in a questions of several seconds per each of the detector, you will have the same consolidated reports which will tell you that you need that many pipes, that many elbows, etc. Okay, let me just switch for a few moments to the team room if there are any questions so far.
Yeah, hi Bernard. There's a couple questions. I think Nick has been doing a good job in answering them offline, but one of the questions was, what's the difference between hole sensitivity and threshold? I think you've used those two terms. Maybe you can give some clarification to that.
Certainly. Let me answer it straight away. Share again. Full Studio. Okay. So, hole sensitivity. Now, imagine that each port, each sampling port, or each sampling hole is a smoke detector. You want to be sure that each sampling point detects smoke with a appropriate obscuration. When you select the hole sensitivity, let's call it column, the target sensitivity is the sampling point sensitivity. Okay. Now there is a small difference between UL world and the EN54 world, because UL world during the fire test is all about the unit sensitivity, which will be lower than 0.5 obscuration per foot. But again, when you consider that the unit needs to draw air and sample the air through 10, 5, or 20 sampling ports, obviously it will dilute the smoke that travels through the pipelines. So the threshold sensitivity is the unit sensitivity, which is sufficient to detect that kind of very small obscuration of smoke that is drawn into each individual pipe. And now, for your reference, if you imagine that a spot detector is around from 3 to 10% obscuration per foot, and in EN54 is from like 1.5 to 2% obscuration per meter, you can imagine that having a sensitivity of 0.5, or for very early warning, if you imagine if you change the settings to very early warning, that each such sampling port can detect the sensitivity of like 100 times or more when it comes to the smoke presence. You can then imagine that you can tailor your general sensitivity scenario or fire detection risk scenario to the actual needs of a given project. Okay. Let me just then spend some time. Let me just clarify that one. If we do the whole sensitivity to make it correct, so I need to change it from settings to some fire detection, so it's not very red. Okay, and we now go into configurations for a few moments. Okay, because that's a very important tab as well. Now, what can we configure? Okay, so generally for starters, if we say, okay, let's start from the top. So we have FAAST XM. We supply our aspiration system to a number of OEM partners, so they can be conventional, they can be addressable. As far as I'm concerned, in Europe, for the time being, we only supply the conventional variant. So this is exactly what you can select. These are the FAAST XM names. So if you are purchasing the conventional, you select, say, 8100. If you are working in China, you would select one of those, the JT1 GD, etc., etc. You will probably know very well, which model you need to select from. Okay, and then you do the facility name, facility location, and all the kind of information that can identify the unit in the project or on site of the facility. You can also set the time. You can also enable daylight saving times, and you can also select the frequency of the trend log. Now, the next tab is called Sensor, and this is where you can manually program or configure the sensitivity thresholds of the unit. Now, this is a very, I would call it, historical tab, when in the old days we had to program the unit sensitivity. Now we have made everybody's work much, much easier, so that you don't have to kind of guess and double check what kind of sensitivity will have an impact on the whole sensitivity, because as I showed you a few seconds or minutes before, when you are in the design mode and you are in this calculator button and then you select the whole sensitivity, you can predefine the whole sensitivity and then translate it into the threshold. So I'm not saying it's a redundant tool, but we left it for the legacy reasons, because it's much easier now to predefine the whole sensitivities rather than the unit sensitivities. Obviously, when you have the different environment during the day, you can transfer the day sensitivities into night. You can also program differently for night or day, and you can certainly also add delays if you want to have the proper smoke risk management by adding it to the sensitivity settings. You can also enable the acclimate mode. The acclimate mode is when you have the risk of changing environment and you want to find, or you want the unit to find the best and the most robust way to deal with the environment when it comes to detecting smoke. So you select the boundaries between each individual thresholds wants to look at the unit, at the environment, and the unit monitors the environment for 24 hours for a most optimum kind of response to the smoke or to the nuisance or dust levels, so that it further reduces the risk of immunity alarms. And then after the 24 hours, it then retests at every hour or every 1 hour. It retests to make sure that this acclimate mode is correct or is proper for a given moment after a while of operation. Then in the network tab, we have everything which is connected to the TCP/IP connectivity of our FAAST family. So obviously you can change the password. I will warn you that you can only change the password to the unit via the PipeIQ. Please be aware that once you change it and you forget it, the only way to change it is by the factory helping you out, and that's quite a complicated process. So make sure that you write the password down. You can have then all the sender for configuring the TCP connectivity. You need to set and configure the IP configuration. Obviously, each unit is capable of sending alert or alarm or trouble messages to one of 6 recipients. So if, for example, I am one of the recipients who are, I could be the building administrator, or I could be a receptionist sitting somewhere, I'll have my email address, and I can select either some item or some actions which I'm interested in, or I should be getting the information, or I can select all. And obviously we have up to 6 email addresses that we can program. The next tab is the airflow. Now, by default, we set the flow boundary before the unit will flag the airflow warning at 20% up or down. Some markets do allow larger flow boundaries. EN34 is limited to 20%. So you can make it to as much as 50%. But from our experience, we would discourage you from doing it, because we want to be sure, and you as a system user, you want to be sure that the limitations or the flow boundaries are as small as possible. So then, in case you have the sampling port clogged or blocked, you have a very quick information about the flow problems. And of course, you can also change the time delays. Again, by default, we have used 120 seconds as a flow delay before it flags it into the warning mode. The user interface, when you have the passcode on the user interface, either XM has got the manual and no LCD, the XT and XS have got the user interface with the LCD on. By default, we have it 111. Now, and then the last tab is Modbus, for those who want to integrate the FAAST family units into the building management system that operates with Modbus protocol. This is just a way to set the password. For a few seconds, I want to go back to the previous one, unless, David, there are some other, because I cannot see the questions from the audience. So unless there are any questions, we can deal with them now.
There is another question. If you want to take it now, or were you going to cover something else? There was something I wanted I know. I wanted to show you something with the FAAST Access NXT. Now, you remember that FAAST XM NXT has 5 sensitivity levels. FAAST Access, our small unit, has the 3 sensitivity levels. Okay. Also, what you can do with the configuration, you can select if the relays which are in the unit, 5 for FAAST Access or 8 for FAAST XM NXT, they are latching or non-latching. Okay, so let's just go for a moment to questions. That, Bernard. So the next question that came up was about hole spacing, and specifically, how do I change one hole spacing without having to change all subsequent hole spacing? So maybe the third hole down on a pipe, but he's finding that it might influence the second and the fourth hole. Okay,
let me go into the unit. Let's make it larger. Let's double click. So let's say when you change the hole spacing manually, so let's say from 10, I will change it to 11, it will only affect the next hole in line. So when you press tab, it'll change to 314. So you will need to change it to, say, your manual location of the hole. But it will always, when you do it manually, it will always change the next hole in line. You have to remember it. Any more questions?
Everyone who's online, if you have a question for Bernard, now would be the time to post it, and we'll take it in the order.
I just want to close with two things about the connectivity. So when you design the system, when you configure the system, you obviously want to upload the configuration onto the unit, and then you want to monitor it. So you upload the system by right-clicking on the unit that you want to connect. Now, the FAAST XM has only the TCP/IP connectivity, so that's over the Ethernet. The XT and XS has also the USB connection. So if you click on connect, it will ask you, well, how you want to connect it. So if you select USB and admin, you have password. As a default, the password is the word password, and then you click connect. Obviously, I don't have the unit connected right now, but you can see the unit connects. And then when you connect the unit, you enable the upload configuration with a right click. Again, you cannot see it now, but it will be highlighted as upload, and then you click on upload device, upload configuration. You can also download the configuration. If you don't know or you forget for whatever reason what configuration you have uploaded it before, it could be yesterday, it could be 2 or 3 or whatever years ago, you can always download it as well. There is an option on it. And then the last tab is the monitoring. When you have the tab in front of you, which will replicate whatever is on the wall, how the unit behaves, what the unit reports, etc. So this is basically it when it comes to design. And one last thing I want to show you is how you connect the pipe from the bottom. So let's create one last unit. I will click on the floor. I will add access. I will click on design, access 2. I'll click on the paper, add the unit manually. Okay. I will make it slightly larger. And then by double clicking on the unit, I will select that I want to have the bottom entry of the pipe, apply, and then when I select my first pipe, let's do it at 3 feet. This time it will be from top to bottom. I have the pipe which I can connect either manually or automatically. Click, and this is how you can connect for the application when you need the bottom entry of the pipe. And as I said, this is very, very helpful when it comes to the raised floor protection, or when you have the water trap installed on the system. Okay, so we can now go to the questions.
Yep, Bernard, let's go to that how we can help you question, and then we can answer a couple of the last attendee questions here verbally. Can we do that?
I hope so. Yes.
Yep. We'll go back into Ready Talk.
Okay, I'm coming back now.
There we go.
So,
okay, so you're seen on your you're seen on your screen. If you would, we'd love to help you with anything that you have a need with. So this is the how we can help you portion. So if Bernard's talked about something that you're interested in, those first couple ones are a data sheet or a product brochure that's specific to the FAAST product line. Go ahead and click those. We do have about a 90-page application guide, which goes into depth for transportation systems, for data center, for hazardous environment, and a whole bunch of other locations. If that's of interest, go ahead and click that one. And then I know at least one of you had commented, hey, I live in Phoenix and I'd like to have a certification class, or I'd like to be contacted by a sales rep, or I'd like you to work on a design for me. So those last couple there are more actions that you're asking us to take on your behalf. We'll reach out to you in some way, so that demo or design or sales reps, go ahead and click those. We're going to leave this up while we have the last couple of questions. And we do plan to stop at the top of the hour, so we'll answer all kind of remaining questions that we have in the time that we have here available. So while people are answering that, let me get to the next question. So one of our guests asks about an elevator hoistway, and she indicates it's about 8 by 8, and she wants a device that's linked to her existing fire alarm control panel, and she's wondering which unit would be available for a relatively small space. She says 8 by 8. I don't know how the depth. I don't know what the number of floors are, but what would we advise, knowing what we know about that installation?
Yes, depending on the height of the elevator shaft, you can use either the FAAST XS. So probably if the shaft is up to say 120 feet, XS FAAST XS should be absolutely fine. If you have larger, up to let's say 200 feet. Probably the FAAST XM would be better because it has a greater length of the pipeline. What I would like to add towards the elevator shaft, but before I want to respond to, well, how do I connect it to the panel? Now, if you have a third-party panel which is not using any of the system sensor protocols, you would select the conventional unit and connect it via the conventional line modules, and then use the relays to report the problems like fire or alert, etc. One last thing I want to mention about the elevator shaft is always, because globally with the same problem everywhere, which I call the nemesis of fire detection, is that most AHJs or regulations around the world require a single smoke or heat detector and at the top of the elevator shaft. And whilst everybody knows that this detector will never work, AHJs or the fire marshals are quite often reluctant to allow for that. So sometimes please, or not sometimes, always, please consult your authority having jurisdiction or fire marshal who has the final say in the building protection design and commissioning, if they are okay to use the aspiration system in the elevator shafts, because at the end of the day, the aspiration system is the best way forward, because you can position the sampling ports at relevant distances, and you can actively monitor the whole elevator shaft along the way from ground floor to the 30th floor. Very often the smoke or the heat detector at the top of the elevator shaft will never see or smell any smoke. And even if there is a lot of smoke, when the temperature is rising, the heat cushion can prevent the smoke from going up.
Mm-hmm.
Is there any other question?
Yep, there's one more question. This might round out our hour for the webinar. They're asking if the programming of the unit is actually done in PipeIQ, or is it done somehow on site? And she indicates here she knows that the password is set in PipeIQ. So programming of that unit itself.
Yes, programming is done via PipeIQ. So first you design the system, and then you send or upload that configuration to the unit. Now with FAAST XS, the small unit, or FAAST XT, the biggest unit, you can program it either via a USB, and you don't even have to power it up. You just connect an unpowered unit via USB, and you upload the program, so you don't even have to, technically speaking, take the unit out from the box. So it can be sent to site in a box, and you don't even have to and then install it and then just power it up, and it will do the baselining and then it's ready to work. With the XM, you need to program it via the TCP/IP, so you need to configure your computer. It's very easy. It's like 30 seconds extra that you need to configure your computer by adding 2 lines in the IP configuration, and then just type in, or you probably even don't have to type in because it's a default, unless you want to change the IP configuration of the unit. So you configure it via the Ethernet cable. So that's the difference between the XM NXT Access.
Very good. Bernard, I think that's going to be a wrap. So thank you for presenting. Thank you for attending on behalf of System Sensor and particularly our FAAST portfolio of products. I want to thank you for joining us today. As a follow-up, we will send you out the information that you've requested if you did reply to that. You also get a video recording that you can share with your colleagues if it's interesting, or re-review at a time that's appropriate for you. Again, thank you for joining us. This does conclude our webinar. Please have a nice rest of the day.